So by default with Flymake, to see what this warning or error is, you can mouse over it and you get a tooltip. And welcome back to episode 9 of Haskell from Scratch. It's about time that I finally implement a suggestion that someone sent to me to get syntax checking working from inside of my editor, Emacs, so that I don't have to keep switching back to the console to compile and check code. So I took a look at a few options and finally settled on Flymake. More specifically, I'm going to be using Flymake Haskell Multi. And Flymake Haskell Multi scans the file not just with GHC to look for warnings or errors, it also runs HLint over the file. So the first thing that we'll need to do is install HLint with cabal install HLint. And so HLint will provide us with some suggestions if we run it on the code of things that can be improved, things that aren't necessarily errors or warnings, but things that can make the code perhaps easier to read or smaller. But I'm not going to look through these suggestions just yet because I'd like to get Flymake running. Now I'm using Emacs, let's see, the version is 24.2, which includes Flymake already, but I'm going to be adding Flymake Haskell Multi from GitHub. And there are multiple ways to install this depending on how you use Emacs. And I have a .emacs that's rather old that's been following me around for a number of years. So I don't know if it's the best way to demonstrate how to install this. So I'm just going to install what I need right now and I'll meet you in a minute. Okay, I'm back. So the way I have it set up, the Flymake mode will activate with the Haskell mode hook, which happens when you open a Haskell file. And you can see already that some of these lines here are in red. And in the mode line, there's Flymake, which is showing us that there's 0 errors in the file and 5 warnings. So by default with Flymake, to see what this warning or error is, you can mouse over it and you get a tooltip. But since I don't like using the mouse all that much, I also set up Flymake Cursor, which allows me to just move the cursor to the line and see the message in the mini buffer down below. So why don't we go ahead and clean up these warnings? This is saying that type of isn't being used, so we can get rid of it. Let's look at the next one. Standard stream and command spec are not used as well. Oops. Then we have a warning that there is a top-level binding with no type signature, which we'll come back to in a second. Let's take a look at the 2 other warnings. Okay, this is saying that target is defined but not used. And as I was refactoring some code last time and passed in this meta-depster argument, I failed to realize that we're not using target anymore, so we can just get rid of it here. And so now we're down to an error here that, notice that we had another warning that disappeared because once we have an error, we're just going to see the errors from GHC. It's not getting to the point where it's displaying warnings for us. So when you get an error like this that's larger than what can fit in the mini buffer or echo area, you can just switch to messages and you'll see it printed out here. So it says it couldn't match expected type. We need to go ahead and remove this target argument from here. And now we are back to 2 warnings. This one is telling us that this E isn't used. And then finally we had the warning from before. And occasionally I like to have top-level definitions that have no type signature, and I think it's perfectly valid. And so the way to get Flymake to stop complaining about this is, depending on where you put your Flymake Haskell Multi, inside of that directory is Haskell Multi, which is a script that it's using to do the actual checking. So there's a GHC line here in the script, and if we don't want that, we can just say no no warn, missing signatures. So now let's go back in, make a change so that Flymake runs again. And now Flymake is showing that there's no warnings or errors in this file. But if you look at the script, what's supposed to happen next is that HLint is supposed to run. And I know from earlier that there were some HLint suggestions, so something's not working here. And if we look in messages, you can see a problem where open bracket is not found. That's a bash specific bit of syntax, but the shell script here is being executed by a standard Bourne shell, which does not have that syntax. So I'm just going to replace this for the time being with where bash lives on my system. And then we'll try checking this again. So let's make a change that'll cause Flymake to fire. Okay, so now we have 2 errors and 3 warnings. These ones are coming from HLint. So let's take a look at what these are. So this is saying avoid lambda, and we're not actually getting the full suggestion from HLint in this case. Here we are, but here we're not. A bit strange. I'm going to try just making a quick change, seeing if running it again does anything, but it doesn't seem to. But I know what this is complaining about in this case. It's saying that there's no point in us having this argument spelled out here when we're just going to use it on the right side. So now let's take a look at this one. It's saying we don't need this do here. And this is a suggestion that I saw in the comments of a previous episode, and it's telling us that we should replace this if then else expression with a list comprehension. And it's actually a suggestion that I don't agree with. So we can go ahead and ignore this suggestion, similarly to how we did with GHC, by passing a command line argument to HLint, and what we want to ignore is named here as the warning, use list comprehension. So let's change that. So we want to ignore use list comprehension. Okay, so let's make a change to the file, get it to update. We still have a warning on this line, but this one is saying use colon instead of ++. And again, I'm not sure why the whole message isn't being shown here. This worked just fine in testing earlier. But instead of doing a list concatenation here, it's usually less expensive to prepend an element. So we have one error left from HLint, and that's saying use and instead of all ID. So if you'll remember, when we were in GHC, the type of all takes a predicate and a list and basically reduces the list to a Boolean, whereas the type of and takes a list of Boolean, which is what we have already. So it'll do the same thing. Okay, so the mode line says now that Flymake is happy. There's no warnings or errors from either GHC or from HLint. So I think we can finally move on to fixing the problem that came up at the end of the last episode. And that was, what do we do when, let's scroll back here, we have a dependency that itself needs to be built by a do script. In this case, the readme.txt that we added to the redo.do file. And I said that redo-ifchange should behave the same as redo, except that it records this dependency information. So the situation right now that we have is we have this shell script that we want to get rid of anyway, but we can't just simply replace it with a Haskell program that does the exact same thing because we need to duplicate some of the functionality inside of redo. So one possible solution is to take some of this functionality, factor it out into a module, and then have both of the command line programs compiled using that module. But I think an even easier way is to just keep everything as a single program, symlink it to redo-ifchange, and then behave a little bit differently when called with the different name. And this is a trick that has been used by Unix-style programs in the past. I think the first example I remember seeing was with BusyBox, which saved on overhead by compiling all of the programs into a single executable and then behaving differently depending on how it was executed through the symlinks. So why don't we give that a try? Let's go ahead and here in main, we'll behave the same as a regular redo, but in the case that we're called as redo-ifchange, after the targets have been built, we'll update the MD5s for all the targets as well. So we'll change this to a do block. And you're seeing the side effect of having Flymake, which I consider to be annoying behavior, in that every time you enter a new line or after a given amount of time, Flymake checks the syntax of the file and shows some errors. And aside from creating some visual noise, it also uses up some CPU time. So I'm going to go ahead and disable Flymake for the case when I enter a new line. I only want it to act when I save the file. So I'm going to try customize group for Flymake. And there is a setting, Flymake start syntax check on new file. So let's just toggle that off, save it for all future sessions, and then go back to redo.hs. So let's try this again. We'll save it and go onto a new line. But Flymake is still running. And the reason for this is that it has this no changes timeout. So after half a second, it's going to run Flymake again. So let's just bump that to 10 minutes, which shouldn't affect us during normal editing. And we'll save that as well. So let's try this one more time. So our Flymake is clean, and it hasn't run now without us asking it to. So the first thing we're going to want to do is get the program name, and we can do that with get prog name from system.environment. And we're also going to need this redo target environment variable, which we can get with lookup environment. And I'm not sure if that's the right name, but we'll see in a moment once I save the file and Flymake runs again. So we'll say redo target is lookup environment of redo target. Let's import it and save. And it's telling us that there's a different error. So it seems like this is the right name. So let's just put a return here for the moment. And now we're getting an error that these are defined but not used. So this can be a little bit distracting at some times, but I'm assuming I'm going to get used to this. So the next thing we want to do is, if the program name is redo-ifchange and redo target is defined, then we want to update these MD5s. So we can check two things at once in a case statement with a tuple. So we'll look at the program name and the redo target. So if the program name is redo-ifchange and the target is just, let's say redo target here, and we'll just call this redo target prime because this is a maybe value from lookup environment, then we'll do something here. Otherwise, we will just return nothing. And so the thing we want to do is, we have these arguments, and just like the for loop here in the shell script, we just want to write out the MD5 checksums for each of these arguments. And we know how to do this already. We have the MD5 prime function. So let's just have another map_m here, and instead of map_m redo, we're going to map_m, let's say write MD5. And we can define write MD5 as it's going to receive an argument which we can call the target, or let's call it the dependency, and we'll write file to some path here of whatever we get back from that MD5 prime on the dependency. And the path that we're going to write to is going to be .redo, and then it's going to be the parent target name, or this redo target, which we'll need to pass in here. So redo target, and we'll need it here as well. So we'll have redo target, and then finally the dependency file name. So let's save this and see if Flymake complains about anything, and it looks like we're okay. So before going any further with the code, I want to show you concretely what I mean here with the redo-ifchange symlink. So right now redo-ifchange is the shell script. Let's go ahead and remove it. Actually, before we do, let's compile redo. Now we'll remove redo-ifchange, and we'll symbolically link redo to redo-ifchange. So now, rather than a separate shell script, we just have a symlink. And so now when we run redo, we get this message that there's no do file found for the target redo.hs. And that's because, let's look at the redo.do file. Remember that we're trying to implement this case where one of the arguments to redo-ifchange needs to be rebuilt, but redo.hs isn't being built by anything. It doesn't have a .do file because we're editing redo.hs directly ourselves. So we need to be able to handle that case. And the simplest thing I can think of is, instead of complaining that there's a missing redo here in the print missing, let's change that to, let's just say missing do. And missing do will look to see if the target already exists. And in the case that it exists and there's no do file, then it'll just say, you know, the target's already there. I don't know how to rebuild it, so I guess we're okay. And I don't know if this is the best way to approach this in the long term, but I think it'll work for now. So we've already imported from system.directory does file exist. So let's say exists is does file exist, and we need to know which file it is. So let's say this will take an argument target. Oh, actually target is already defined here at the top level, so we already have it. And so we'll say unless the file exists, throw this error here. So let's try compiling that and see if it takes care of our problem. I'm just going to remove the .redo directory. And it's giving us this error once, but that was just while it was recompiling. And so now it looks like it's working. But let's do a couple more things to clean up the code here. One is that, again, we're using .redo, the directory name, in a couple places. So let's just say the metadir is .redo, and we'll replace any instances of it in the code in two places. And then also we should handle the case where we're being called as redo-ifchange, but we don't have a redo target environment variable. So we'll just throw an error here, missing redo target environment variable. So now we've fixed up some warnings and style warnings about the code from HLint, and since Flymake is running, I'm reasonably certain I haven't added any really obvious style errors. And the amount of code that we changed in this episode wasn't very large, but I think it had a large impact on the code, because it's now going to allow us to write our do files in a more recursive style, which is what redo was designed to do. And while I'm thinking about it, we don't actually need this readme.txt dependency here. So I think this is a good point to stop this episode at, because there's no obvious problems still remaining. We might run into some shortcomings or design flaws later on, but we really need to have a more complicated project that we're building to see if that's happening, and also to motivate implementing the next features of Redo. So, thanks for watching, and I'll see you next time in episode 10.